Okay. First of all, I want to introduce my partner in this lecture and all my talks. He has the protagonist of all of lectures and all of talks. He's a Wolfgres, a young, smart, and handsome, and very intelligent DBA in a company, right? So he notified in the company text slow performance. And Wolfgres, are all DBAs, tries to understand what happened in the database, right? Check it, the indexes, check it, the queries, track the all connections, and all of, we need to check like a DBA, and detect, but the workload for the DBA increased a lot, right? Wolfgres worked in a company, the financial, in a fintech, and have a new users, a lot of new users, maybe millions of users, and increase the all load of the nodes in the database. Maybe this is a normal situation for any IT consultants and developers, DBAs, and something like that. So dreaming with work, dreaming with bugs, dreaming with case story, dreaming with tickets and something like that. So Wolfgres dreaming with this problem, right? And maybe it's not just a ghost, maybe just his brain. And his brain said, slow performance, okay. It's a low performance if you deploy a multi-master replication, a multi-master, right? Okay, sounds really good, and wake up to the whole weekend at the early night and thinking, okay, what's its core, or why we don't implement a multi-master architecture to support a new transaction load? Okay, why not? So after the next day, Wolfgres take your work, but not really your work, just Google, take the time to update the new project in PostgreSQL to implement multi-master replication, okay? Check it all tools, in the history tools, maybe we have a Bucardo. Does anyone use Bucardo here? No, nobody. I used, and maybe I take some tests and POC in Bucardo many 6 years ago. This project has development in parallel with some scripts and try to perform a multi-master replication. I think it's not enough for real production environments, and Bucardo tried to perform this multi-master replication with the triggers, and something is too hard and too cost for the database maintains, because the performance is slow with the extra transactions with these triggers. So I worked to approx maybe 8 years ago with this proposal here, and I use PostgreSQL XL. Maybe it was a good proposal to try to distribute transaction with different nodes. It's similar, or maybe the high-level architecture with PostgreSQL, Postgres XL is the similar architecture that MySQL cluster or MariaDB Galera, right? After that, Wolfgres checked the new project and the availability, because this project stayed in the version 9.5, and this in the same version state. That's it. And we have two new proposals for deploy multi-master replication deployments. This is a Postgres BDR, okay? And I tested Postgres BDR in the version 9.4, and after that is the licensed project. And we have a pgEdge platform, okay? So I like it because it's open source. Why not? Which okay, we can try to use it. So after the little history, born this talk this is multi-master replication with pgEdge. Okay. This talk is the first approach to extension, and I want to talk to you, and I want to talk to you about or experience implement a case of a study. This case of a study born because a customer want to implement the multi-master replication maybe the last year, and this customer want to implement this project in 2 weeks. The customers maybe sometimes are very crazy, but in this case we didn't not implement in this time, but we decide to create a case of study for really testing how this works and how it is worked in multi-master replication. Okay, so my name is Alfredo Rodriguez. I'm from Mexico, and I'm very happy to be here because it's my first time here in Prague. My first time to talk in Europe. I am PostgreSQL architect with a external consultant in Wolfgres, and currently work in DBA Senior in the full time in Story. Story is a fintech in Mexico. So I used PostgreSQL since 2010, and I love open source. Really, the open source is my love in this, and I love the PostgreSQL community because it's a really great community. The community PostgreSQL support all of like me, and many people call me Draco because I have a heavy metal band named Draconia in Mexico. If you want listen notes, you can find those in YouTube Music, Spotify, like Draconia. I am the guitar and vocal for this band. And thank you so much for the opportunity. It's my first time here in Prague and my first time in this event. Thank you. So I talk about and try to introduce the case of a study. The case of a study of we try to deploy and migrate the normal replication and implement a normal deployment to a multi-master. And we, in this talk, perform step-by-step this migration and talk about you how many things we discovered in this process. So. Yeah, my apologies if sometimes I stop to speak because I continue thinking some words in Spanish. So I stop to say, I remember, how did you say in English? Okay, you understand me. So the case study is this database. We have the principal tables and relationship within is the financial APP. Okay, is the financial APP with different relationship. We have a customer contacts. We have account types, operation, and transaction. The principal tables that receive the all load in this case. We have the account, transaction, and operation. The transaction is the most important thing because this table have the all transaction related with account and the operations related with transaction. These 3 tables have the all load of transaction. So in this case, is a normal implementation, okay, in normal cluster that we checked. In this cluster, and this cluster is an on-premise. So we want migrate to a multi-master with pgEdge. But first for all, we need to find what is pgEdge. Okay. So pgEdge spock is the extensions. And this extension have to provide a multi-master application. Okay, start development at the PostgreSQL version 14 based on pgLogical and BDR. Take the same concepts and use the old pgLogical concept. So, and Spock, this extension especially, is part of the PG distributed Postgres. Okay, Spock have the same term that PG logical, that nodes, that the real nodes is the PostgreSQL instance. This instance is the databases. So providers as subscribers. Okay. Instead, PG logical Spock not create a publisher. When we create a new, automatically create in this case the publication and name the Spock is the same. The publisher is provider, right? And subscribers is same subscribers. And we have, like in pgLogical, we have a replication set. It's a collection of tables. We explain those better in the next slides. So pgEdge platform highlights. We have the principal two extensions is the Spock. What this extension highlights have automatically replication of DDLs that pgLogical doesn't have this, and replication partitioning tables that at same that pgLogical doesn't have this, and we have a conflict about it. We talk about and special take time to try to explain how this works, this conflict avoidance, because I have my personal opinion about that, but in the next slide we explain that. And finally, to try to complement this replication, we have other extensions to be part of pgEdge, and this extension is Snowflake sequence, right? We explained that, or we explained all in the next slide. So, Spock deployments. The Spock and pgEdge proposal that these deployments, okay? I remark in red the different deployment and the extra deployment that we have already in pgLogical. If you use pgLogical, we have all these. Okay, this is operate between major versions. We can do with pgLogical for database replication. We can do with pgLogical and streaming replication too. Selective replication datasets with specific tables. We have the same with pgLogical. Selective replication, the same here, and the same here. Okay, but the difference with Spock, we have implemented two features extra. Now, these two features: asynchronous multi-tick replication with conflict resolution. Okay, the next one is the merge multiple upstream servers. Okay, so we have deployment different types of the structure, different type of clusters to try to distribute. Maybe if we understand how this works as Spock, we can deploy and to try above the conflicts, because sometimes in conflicts is not enough for production database. So, okay, with all of context, we have start to migrate. Okay. The first one is select architecture. We replicate the same architecture in this case on-premise, okay? And we migrate the schema. The migration of schema is really simple, okay? Adapting features to try adapting feature, and finally stress testing with the same test for the for two environments. And finally, we take some conclusion, right? Okay, our laboratory, okay, we have two deployments. One is a normal deployment, stream replication with 2 nodes, okay? And we have the same nodes, but in multi-master replication, right? All of in Rocket Linux, okay? And with 4 gigabytes in RAM, 2 CPUs, and the same storage for both. Okay, this I forget tell you. You can check all step by step and test yourself this in this URL. The case of study pgEdge have the schema, have instruction for implement the both architectures, and you can follow the instruction to implement and deploy that. Okay. So, okay, on-premise installation, in this case, on-premise installation with pgEdge, we installed a binary. I think I will report the developers that need more debugging log because showed some errors like that. I can't connect with the port. Okay, you change the configuration, that I can connect the same error. But we install this port, okay, configure, create a JSON template to configure the cluster. Okay, aquí, here we set the public IP, private IP, and some. You check the parameters. It's really simple to understand. And finally create the cluster, okay? Validate the cluster here and init the cluster. So the pgEdge start to install, okay? This pgEdge install extension, a fork of PostgreSQL code, pre-compiled, installed in our server or servers, and after that take some time, okay, and after that we go. Oh, okay, so sorry. Okay, so one thing. Take some minutes, really, okay? So the pgEdge bin installed 2 nodes, okay? We installed in 2 nodes, okay? And automatically deployed the nodes and all the extension inside the database, and different database. So we have here node 1, okay? And create the data inside this, and different here. We have in different hosts, no problem with that. If you test this code in or the same host, no problem. It changes port automatically, the change port. So create the nodes here, the node 1 for this IP, and create the second one node. So we can use this Docker. We prefer install manually all to try understand what the difference, because before to state in Docker, but you check and test it really fast in Docker. So we can check this in tutorial in this URL. Okay. So after what happened? What happened here, and what is the proposal of pgEdge and spock to use the multi-master replication? When spock create a node, this node create a publication that's a name provider in spock, and the other node subscribed automatically. Okay, so we have replicate here to here because node 2 is subscribed to node 1 at the same p logical. That vice versa is the same thing. We have node 1 with like a provider that node 1 with subscribed the node 2. And the replication is the node 1 to node 2. The same thing, but the complex, I explain what is the complex or new proposal for this deployment to the next slide. But we have the multi-master because we have 2 subscriptions in the same way. Okay. So after the subscription, the spock create a 3 replication set by default. Okay. We need to remember and keep in mind these 3 replica sets in the both nodes, because we explain what is the proposal of these replica sets. Okay, each one, and we have 3 defaults. Default is the first replica set, and we have the second one, default insert only, and finally DDL SQL in the both. As we can see, each one have a different ID for each one. Spock have a lot of functions that we use to add or create a new replica set and try to generate new replica sets in different ways. It depends on of do you want in the deployment, we can create, alter, drop, add tables, add the tables, the database from node database, and that's all. You can check each one in documentation. But what happened? Okay, in this step we installed the new application. We have 2 nodes, and these nodes are subscribed between them. Okay, one direction for he, one direction for her. Okay, but we doesn't yet a multi-master application because we doesn't have a tables here. Okay, so after that, the steps is just manually. At the tables, I am create a schema. Okay, create these tables manually, and after that, I add this table for the replica set default. Okay, what happened here? When I execute this code and I execute these 2, in this case, these 2 functions, we have a table add to the replica set and add the sequence. We talk about the sequence to go. We have this, just one node replicated to node 2, but vice versa, don't replicate. So we have multi-master node, really node. Because of that, we need add to the replica set the table. Okay, from aquí. We are here the replication set table. The node 1, okay, I replicated you, but the node 2 is not the same. So we had the same process. Okay, the same thing in this here. Execute the same code. Okay, I create the table, and after that create the table, I add in the node 2 the table. Okay, then the table and the sequence, and we have now the replication, the multi-master replication here. So we have replicate from node 1 to node 2 with this subscriber, with this subscription, and vice versa with node 2, replicating to node 1 with this description. Okay? So now we have the both tables and the replication set. All good. But do we need to create all tables manually? Spock try to improve this part using an automatic DDL replication. And you remember the replication set, we have 3 replication sets. The last one is for this part. Okay? We can activate these pictures for Spock using this code. And after that, we can, the all replications, the all tables, add automatically and the replication set in both nodes, right? So this impact, we have 3 different here, and any tables created with a primary key add automatically when we just execute a create table, this table, and we have enabled this automatic DDL replication. This table add for this replication set. If we erase primary key constraint, the table add to this, and if we unlock the table, go this not replicate between them. Okay, and we have 3 this impact for 2 tables here, and finally this replication set is put to replicate this code. All this code that here set and tracking in this replication set. So, okay. So limitation of DDL automatic replication is we can't execute and not replicate drop table because we broken the replication on create a table as. And we follow win commands, don't replicate like create database because the subscriptions attached to database specific. We don't create database, alter database, drop the database, alter system, and all. And unfortunately, to get a create index concurrently is really great, this stuff. So what happened when normal sequence? All DBAs know that the sequence, normal sequence, begin with big big integers. And integers is a disaster for, for any database administrator. And if we use a multi-master replication, it's a really disaster. So in this case, Spock proposal, the new extension that we talk about in the above the slide, and the snowflake sequence. I talk about the snowflake, try to generate a unique differential to index, or not index, to primary key, to difference with three principal things here. The first one, it's 40-bit value representing with milliseconds, okay, with epoch. And unique ID that with this milliseconds, the relation with epoch, and plus the node number, okay? With three fields, each node in the snowflake node have a different ID. With three fields and three configuration, we view the new generate ID with the snowflake or sequence like this. Inside this, we have a milliseconds target with a epoch date and with node date. Okay, the difference is a huge difference with normal sequence, like if you create a table with big serials. Instead, help us this configuration as Snowflake help us to perform a good difference in multi-master replication with different ID for primary keys. So it's recommended for deployment. But what happened? Okay. I hope so far so good, because we have tried to finish to explain it of case of study. So what happens if we have two transactions in the same time in both nodes? It's the topic of the really problems of the old implementation that multi-master replication, okay? The conflict resolution. In this case, Spock tried to propose the algorithm named conflict-free delta apply columns. Okay, and in the summary, because maybe we didn't go too deep to try to understand how this works or something like that, so the last update wins. I think this algorithm, in the same specific cases, have a really hard problems with the consistency because of that. Okay, I explain you. I will explain you. So, in this case, we insert in the first node. Okay, we insert a value for a customer, a specific customer, right? Generate with a Snowflake ID. And we have this part. The node 1, 2, node 2, right? So the node what create an update, right? But in the same registry, in the same tuple. We have a plus 1,000, okay? 1,000 crown or 1,000 pesos mexicanos. Anyway, so you remember that this transaction didn't commit, right? What happened? The other node. In the other node, we have a different transaction, and plus here. The old is the 1,000, and the 1,000 plus 5,000. And commit here, right? But in this case, the old not commit yet. Finally, the commit, maybe this replicate here, but after that, commit this part. The node what finally commit. What happened here? Spock detect a conflict. Okay, because the same the same tuple has been updated, okay, with both nodes. It's maybe complex to understand just reading here because the last update was the second node one, and maybe it's too hard to understand how, but we check all resolution here. Okay? So what happened really? When we start the transaction, we have always the same value is the 10,000. Here is the independent node with independent x-wall, with independent memory, with independent from here. And the same thing here, when the start is the different page, different x-wall, different all. Because of that, didn't have communication, the specific to the granular pages. The both nodes doesn't have communication. For that, in this case, to resolve in this case the conflict, take the last transaction. Okay, for me, the last transaction is the old 2,000 plus 10,000 plus 1,000. That's it. For the order that execute before this commit, don't take this change. Okay, I think in this case spock, we maybe function correctly and the functionality is great for maybe an deployment with the split specific insert or updates for each node. Maybe it's just a quick example. Insert here and update here. That's it. If we merge maybe this case of the update, we have problems with the consistency. Is the result, is one of the result of this test, and for me, and special for team, didn't like how to resolve the conflicts, right? So for that, if we to update for the both node, we have our really problems with the consistency of the data. So finally, to try to go to a stress testing. Okay, and we perform this test with the pgEdge. It's really simple. 5 minutes with the benchmark with 5 clients. Okay, 2 jobs, and we need as small as single, in this case, a load Wolfgres SQL that generate inserts with in a table to try to generate the new insert for that. So the first benchmark that execute is the primary and standby. That's it. One write only on the node A. That's it. Node 1. And we have the next results. Okay, the number of transactions. Okay, that's good. Latency, average, and all these results. The next one, okay, is the test 2, primary to primary, but it's too important in this case. We use in this test normal sequence, not use normal sequence. You use a normal sequence. But what happened here? Okay, the latency is reduced and increase maybe 10,000 and transaction. But the reality of this is we have a lot of problems with replications primary keys. This maybe a 30,000 inserts having problems with the primary key. Okay, not all it's inserted, not all it's replicated, and we have different inserts between the nodes. So the next in the next test, and next one, we have two nodes, primary and non-primary, but in this case, with snowflake sequence, with this extension, right? We have a list, maybe 10,000 less transaction. The latency is maybe similar, and we have this result, but all data is replicated between them. In this case, just in this benchmark, we just execute the insert, not updates, not select, no, just inserts. So, summary of stress testing. So defined transaction per second. Most when is the primary now snowflake, but the problem here is we have a real problem with the replication in this case. The second sense, this is okay, the transactional number of transaction processes, because we check the difference between them. This makes sense like this with this, right? With the replication and latency between them. And the latency, we have less latency here, but we have a disaster with the replications and integrity between the nodes, and less latency between them. And finally, average connection time. Okay? With the connection time, pgEdge balance, or try to balance between the more. Because of that, we have the more connection time in two tests here. So, conclusion. We have, after this case of study, the team, we have a conclusion on how this works, and maybe the pgEdge spock multi-master replication help us, or really help us to improve that. Pros is open source. I liked the project open source. Second, is based in PostgreSQL. All projects based in PostgreSQL are good, and open source is really good. Based in pgLogical, nowadays we have a lot of production deployment with pgLogical. And if we use especially and designed to a spock performance, we can deploy a distributed geographical. Okay, so we have the ACID compliant too, and finally we can maybe deploy a different type of deployment with a read-only nodes. So cons, we can currently today we can only deploy 7 nodes so far, no more. This test is over version 4 and continuing development. We don't use in production. Resolution conflict doesn't guarantee the data integration between nodes. And mainly by network lags, we have a really disaster to integrity. And we database depends on design to spock. I think our application depends. If we want to use in spock with multi-master, we need design to spock, especially. So, okay, to final, how to define pgEdge spock, and I want to refer my conclusion with a joke, a Mexican joke, a Mexican meme. This is many people that low income like me in Mexico have this car. It's a Nissan, it's China's, no, not China, Japanese car. It's what's my favorite cars, and I had this car. And it's, if you meet a Mexican, you tell about the suru tuneado. This is a joke. This is maybe a normal situation in Mexico. You walk in the street, you see a suru tuneado in maybe in a corner on the semaphore, something like that. But spock is a suru tuneado. What does it mean? That we have a pgLogical like this, okay, and the pgEdge is the same thing, but maybe with this and this, and sometimes like for here, and we have just pseudo-tuneado. I today don't recommend you for productions. We need we need test a load. We continue work to try and study and report and try to improve the code. Okay, it's a great proposal because it's open source, have nice things, but we need run more tests over the old. We can stress testing with update especially to try to report this performance and try to improve the development team. And obviously, we missing the test and analyze the party union tables and replication and test it. So we continue in the team to try to test this tool and try to report the all of we can't. So someone have any question? I hope no, because you can send me by email or something like that. Okay.
You said that in config resolution that your main. You said in the config resolution your method is last write wins, right?
Yep.
And are there any other options like you can write your custom rules or some merge logic?
No, not really. We have currently is just the only config resolution automatic. The config resolution, we don't have custom maybe a custom algorithm is the only proposal for nowadays.
Might happen. Okay, thank you.
Thank you. So, any question? Okay. Thank you. Hi.
I think I remember that you said that the snowflake sequences are computed from current time.
Yep.
So what happens if you change your time to 1 second or more back? Because don't you get duplicate sequence numbers then?
Okay, the proposal of Snowflake is use the time and millisecond with a special algorithm. We have the most random value, not especially relate with the date or time. Just try to, if you have different times, maybe a time configuration in both nodes, doesn't matter because the value try to generate a different value for it.
I mean, on the same node, for example,
Okay.
you restart the server and it just happens to boot with time set 1 hour before.
Okay, I don't know. I need to check it and I go to my homework. And thank you.
So, any other questions? If not, thank you for the talk.
Thank you so much.